So we've been talking about congruent triangles, and we've been spending a couple days going over congruent triangles, and there's a couple things that have come up and been very clear through what I've seen. Basically, we do the puzzle proofs for you to start getting a first idea as to how proofs go by just putting the pieces together. And some people were just, I mean, let's face it, some people were getting lucky guessing. Some people were starting to get what's going on. But the one thing that's really clear through that whole process to me as I was watching all the different classes doing all the different groups within those classes is one of the weaknesses that people have is they don't understand the vocabulary still. And we're still struggling with that. So when it says bisector, you don't know what to do with that. You don't understand what a bisector is, which is one of the reasons why hopefully you still have some flashcards that say bisector. That's a big word. You're going to learn there's just maybe a handful of terms that we're going to use over and over and over again in proofs. Things like midpoint, bisector, parallel line theorems we're going to use over and over again, vertical angles, reflexive property for sides. Those are the things we are going to keep working on and keep seeing. So hopefully through repetition over the next few days, you will kind of pick these up a little bit more and see the structure of the proof. But again, just some quick review stuff before we get into it. Here I have two congruent triangles. They are congruent. And you can tell pretty much what sides correspond just by looking at it. So if I were to make a congruent statement, I would say triangle RUN, R to U to N, would correspond to what triangle? Triangle, okay, angle R would correspond to angle K. Angle U would correspond to angle YS. How about SKY? What if I did that way? S corresponds to N, it's the smallest angle. Okay, K is the middle angle, so that would be, and Y is the largest angle, so that would be U. So again, when we name congruent triangles, we have to name them in corresponding order. That's from our last quiz. And identifying corresponding parts is really important. Angle N corresponds to which one did we say? Angle N is congruent to angle S. S. There we go. The measure of angle U is the measure of angle Y. And RU equals KY. Now what does it mean when I write RU without a symbol over it? It means the distance between R and U, or the length of segment RU, which is why it's equal to and not congruent to. If with segment RU, it would be congruent to segment KY, but the lengths are equal, because the length is a number. Numbers are equal. Yes, this represents a number, not the segment itself. So corresponding parts is a pretty critical concept in order to do congruent triangles. Because really, what we're doing in our proofs is not, we are proving congruent triangles, but really we're proving corresponding parts are congruent. That's our focus. And we build enough corresponding parts, then we get the congruent triangles. But that's what we want to be doing with our proofs, is proving corresponding parts congruent. Now, folks, this requires your undivided attention today. That means heads up, books away, electronics away, making sure you're really focusing on this, because this is pretty critical stuff for the rest of the year. So please. Proving triangles congruent. And these are some pages that you may want to then print out once the internet is supposed to be back up in about an hour. Fully back up. That's the estimate. Now I'm not sure if the rain is slowing them down or not. Pardon? Inside the school here, it's working slowly. It isn't fully back to its full. We have a backup provider we're using right now, and it's about a third of the normal bandwidth that we get. So about a third of the data we can get, and they've shut down a lot of stuff just to streamline that. Right now, you can't Google in from outside the school. You can only do it within the school.
Why would you be outside?
Don't you ever access your homework from outside school? Don't you ever go on, when you're at home, to go on your Google Docs to look something up to work on something? Yeah. And it's still down this morning until they get the internet back up here. The Milton Google. The Milton Google Docs? In school or at home? In school it's fine. At home you can't get in. They got shut down from the outside. It's fine with, they were able to maintain some stuff. So hopefully the internet will get back up a little bit later. But when it does, we'll get the website back up and we can print out the notes, because the website is one of the things they took down too. From outside. From inside we can still access it. All right. So proving triangles congruent. Strategies. One strategy is to prove one part, either a pair of sides or pair of angles of one triangle is congruent to a corresponding part in another triangle. That's really our main strategy, right there. That kind of sums the whole thing up. I want to prove corresponding parts are congruent, which is why we started out talking about corresponding parts, because that's how we do this. I want to prove corresponding parts are congruent, then find another pair of corresponding parts and prove they're congruent. Then find another pair of corresponding parts, so I've got 3 pairs of corresponding parts congruent. Then check to see if our parts make up one of our shortcuts. And by the way, we could include HL on that too, as one of our shortcuts. So we first start not by trying to do the whole thing at once, but by showing corresponding parts are congruent. And once I have 3 pairs of corresponding parts congruent, then I check to see if that fits, and I have a shortcut for triangle congruence. Yes?
What 2 words does HL speak?
Hypotenuse, leg. Right triangles only. Now to prove parts are congruent. So great, so I want to prove parts congruent. How do I prove parts are congruent? Here are some basic ideas how we can do that. If I have a shared side, should be a S-I-D-E, not S-I-Z-E. I think some stuff auto-corrected when they updated versions, and I don't know why. Side, okay? We could have a shared side. If we have shared side, our reason is always reflexive property. We can have vertical angles. And we saw that a lot in the samples that we did the last couple of days. We had vertical angles. That was vertical angles are congruent is the reason. We could have givens about something to be a midpoint or a bisector. If I'm given something's a midpoint or given something's a bisector, we use a definition of midpoint or bisector to conclude either congruent segments or congruent angles depending on what is being divided. By the way, if it's an angle bisector, I'm going to get congruent angles. If it's a segment being bisected, I'm going to get congruent segments. Okay, I don't get angles from segments, and I don't get segments from angles. Doesn't work that way. You don't get apples from a pear tree.
Well, you could.
No, not really.
You name a tree.
And that's not a pear tree anymore. All right. Again, more strategies. Worthy of repetition. Look for vertical angles. Seriously. Look for parallel lines. If I have parallel lines, if one of my givens is about parallel lines, and this is just in general, if I'm given something about some parallel lines, I'm going to start looking for a transversal. And if I have parallel lines and a transversal, then maybe I have some alternate interior angles that have to be congruent. Or maybe, just perhaps, I have some corresponding angles that are congruent. Or some alternate exteriors, or something like that. But whenever I see a given involving parallel lines, I'm going to look for a pair of congruent angles by using like alternate exterior or something like that. So there's a strategy we're going to use. But again, you have to understand and remember the angle pair names and their relationships. Look for givens about congruent angles. I mean, if they give you some angles that are congruent, then yeah, that's pretty safe. Or givens about angle bisectors. Look for perpendicular lines. If you have perpendicular lines, generally you saw a couple times in the puzzle proofs, we went from perpendicular line to they form right angles to they're congruent. We can also form right angles to then conclude they're right triangles, so I can use HL. Now, every proof is different. That's the real trick here. What I'm doing is I'm filling up a toolbox for you with all sorts of possible strategies that you can use. So you've got 20, 30 different tools to choose from, but you have to pick the right one because everyone requires different processes. Every proof is going to be a little different. And that's what makes proof challenging, is that it's very much a puzzle-solving situation. You can't just do the same thing every single time and get the answer. You might do similar things, but very rarely will it be the same thing. Again, our reasons why triangles can be congruent: angle, side, angle, 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 side, 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 angle, side, and HL. And we've been working with these for about a week now, so you should be familiar. Which one do I have drawn out in this picture here? Which shortcut? If that's my picture, which one would I have? Yeah. That's angle, angle, side, yes. So obviously one of the strategies here that we use is to make sure with our proof we include a picture and mark the congruent parts when we prove them. So if suddenly I know that angle C is congruent to angle F for some reason, I'm going to mark that. And BC is congruent to EF, I'm going to mark that. So I can look at the picture and see my corresponding sides, and maybe I can see which theorem I'm using rather than just looking at the words. Pictures make a big difference. All right. So let's take a look at this and let's do it. Let's do some proofs, because this is what you're going to be doing tonight in your homework. You're going to have some proofs to do. Talk about a good assignment for Halloween. It's about as scary as it gets in geometry. Okay? All right. So whenever we have a proof, the first thing we're going to do is going to set up our two columns. Just like you had. Statements go on the left, reasons go on the right. I'm given OAE and OI bisect each other. Segment AE and segment OI bisect each other. So I'm going to start by giving that. OAE we always start with some sort of a given. Now, given is a reason I can use. I may never use the word prove as a reason. Prove is never, ever a reason. If you take this word prove right here and you write it down as a reason in a proof, it's automatically wrong. It can never be used as a reason. When can we use prove in the proof? Never. And that by never I mean never. There are no exceptions. You may not use prove as a reason. Okay? I didn't say you couldn't use the word prove in some other sentence. I said you may not use prove as a reason. Okay? But what this does tell me, this is my finish line. This is not going to end well today. It's going to crash again. Oh, yay, I love when it does that. Try again. Okay? That is the finish line. That's where we want to end up when we're all done. Those are the triangles I want to prove congruent. So, how do we do it? Well, I look at this statement. Is there a vocabulary word used in this statement? One of the vocabulary words we've learned so far this year. What is that word? Bisect. So immediately I want to, since I'm using the word bisect, immediately I want to, right after I've used that word in a statement, what does that mean? What does it mean to bisect? Okay. They're intersecting each other, but they're intersecting in a special way. How so? Through exactly the middle. They're splitting each other in half, right? Because they're bisecting each other. They're both being bisected. So if that's the case, what segments, because remember, what's our goal here? I want to prove either pairs of segments or pairs of angles are congruent. segments are being bisected, I'm going to get congruent what?
Angles.
You're getting apples from a pear tree. No. If I'm bisecting segments, I'm going to get congruent segments. Okay? If I'm bisecting angles, I'm going to get congruent angles. So I'm bisecting segments, I'm going to get congruent segments. Which segments are being bisected? Well, AE is being bisected, so what congruent segments am I going to get from that? Yeah, I'm going to, so I can say AM segment is congruent to ME. Okay, I'm going to mark that on my picture right away. And what else?
O, M, and I, M, or MI.
Okay, now they aren't all congruent to each other, but I get that both from what reason? Definition of bisector. Because that's what it means to be a bisector. Okay, or definition of bisect. So what do? We use a vocabulary word, we use the definition of that word as a reason to make a conclusion. What did we get? We got two pairs of congruent sides. Now, I could do this separately or combine it because it's the same reason both times. I combined them, but I could have done this step 2, and step 3 would also be definition of bisector then. Okay, I've used that up. I found my congruent parts. I have 2 pairs of congruent parts. I need a 3rd pair of congruent parts. Where am I going to get that? I've got no more givens. Vertical angles. So, angle what? Good. Is congruent to, I said theta instead of O, but that's okay. AMO is congruent to IME. Angle IME. Sorry.
If it's rotated, is it flipped or rotated?
Yes.
So, would that be
And my reason is, again, vertical angles are congruent. Okay? It's not just vertical angles. I have to write out the whole statement. Let me be really clear about this, okay? Look up here, folks. Come on. I got too many people with their heads down still, not paying attention. This is really important. When we're using vertical angles, the reason we have to write vertical angles are congruent. Not just the words vertical angles. Vertical angles are congruent is a theorem. It's a very specific statement. You could also say vertical angles theorem if you wanted to. But if you say just vertical angles, that's not correct, because definition of vertical angles does not guarantee they're congruent. We need the theorem to do that. So we have to say the phrase vertical angles are congruent or vertical angles theorem as a reason. Now, I have 3 parts. I mark it. I have 3 parts. Do I have congruent triangles? Is that enough? 3 parts is usually enough. Now look, are they in the correct order? Which order would they be? It's side angle side, isn't it? I do have 3 parts here in the correct order, so SAS is going to be my reason. That's my shortcut. What's my triangle statement? Well, instead of struggling with it, I can just look. This is what I'm trying to prove, right? Triangle AMO. Congruent to triangle EMI.
that annoying?
Yes.
What is it doing?
It's glitching. That's why I know it's going to crash soon.
Where are you just
Okay.
Or crashes?
Well, because I already got enough stuff on there. I can always podcast it next hour if I have to, or re-save it. So there's a proof. And that's kind of the thing you're going to be expected to do today on your own. So let's do another example. Okay? Now this one has a lot of givens. Hooray, I love givens. All right? Given. Start with the first one. AC is congruent to EC. Well, that's fantastic. I don't have to do anything or use any definitions. I just have that they're congruent. That's one part. We're good. Move on to the next given. AB is congruent to ED. Again, that's given. I'm going to mark it on my picture. So obviously when you're doing these in your book, because they give you the picture and everything in the book, when you're doing these in your homework, I need to see the picture that goes with the proof. You need to redraw the picture. When you redo this problem, don't just make the two columns and go, I want to see the picture. I want you to list the givens and what it is you're supposed to prove, and then do the two columns. Do the whole thing. It takes a little more time, but it's worth it. Yeah.
Does it matter if, like, if it doesn't give a specific direction on how to draw a triangle? I mean, will it matter if we, like, do, like, a triangle like that or that triangle?
I would try to copy the picture as closely to what they have as you can. Yes. Yes, I would. Yep.
Did you say after this we're going to be doing our homework?
If we have time, once we get through, yes. Okay. Now, I used a vocabulary term there, didn't I?
Yeah.
What vocabulary term did I use? What does a midpoint mean? Directly in the middle. So what congruent segments are, and I'm going to get congruent segments from a midpoint or congruent angles? Segments, because angles don't have midpoints, do they?
No.
Come on, guys, heads up. It's like the third time I'm having to tell some of you. Seriously. Eyes up here. So which segments are they going to be? Which ones did you say? B, C, and CD, yeah. You get to answer all the questions. Let someone else have a shot. BC is congruent to CD. Reason? Definition of midpoint. Now, is that enough? I mark it on my picture. I have three parts. Is that enough for congruent triangles? Which shortcut? Side, side, side. That's my reason. My statement's going to be what I want here. ABC congruent to EDC. So there it is. That's a proof. Very much at the level of what you're probably going to see in your homework today. Now, for some people you're seeing this right away and you're going, this stuff is a piece of cake. I don't see what people are complaining about. For other people, it's like, where did that come from? How did you know how to do that? Well, repetition, patterns, stuff like that. I mean, really, these givens were freebies. That's a pretty easy one. B is the midpoint of segment AC and AD is congruent to CD. Prove the triangles are congruent. Okay? So, which given would you like to start with?
The first one.
The first one? So let's start with the first one. B is midpoint of AC. Given. Now before I dive right into my second given, I want to exhaust what I can out of this. What vocab term do we use? Midpoint. Okay. B is the midpoint of AC. Let's see where that is. There's B, there's AC. What am I going to get congruent as a result of that? AB and BC. Reason? All together, everyone said?
Definition of midpoint.
All right, I got some congruent parts. Now I'm going to go look. Do I have more givens? I sure do. Next given, AD is congruent to CD. You're right, I should mark that. So AD is congruent to CD. Is that definition of midpoint? No. It's just given, right?
Yeah.
Okay. I'm all out of givens now. And I'm all out of midpoints and stuff like that. So what do I have left, Leah?
You have right angle.
I have a right angle? How do I know I have a right angle? Do midpoints make right angles all the time? Really?
But you have right
I do?
bisect.
Bisectors always make right angles? No, you're jumping ahead, okay? When we're done, we will be able to there would actually be a way we could show when we're all done that those are indeed right angles. But right now we do not know that, and we cannot jump to conclusions. But what do we know? Shared side. There we go. Good. I knew you'd get it. Okay? You're right. They are going to be right angles in the end. But we don't know that yet. We can't jump to that. So 4, BD is congruent to itself. Reason? Okay, what reason do we use when it's a shared side? Reflexive property. Okay. Do I have enough for congruent triangles?
Yeah.
Which theorem? Using shortcut of side, side, side.
Mr. Dorn,
Yes.
could BD also be considered the midpoint of AD and DC? Or whatever? Because it splits essentially.
Okay, you mean the bisector of this angle?
Yeah.
We could prove it later, but we don't know it ahead of time. We don't know that now. That's something we can get later.
Same, so that means it's the same length, and if that's the midpoint of the AD.
You'd have to do some extra work. You're making assumptions. Okay, you're going beyond what we're just. You got to really, in some ways, you almost got to think smaller. You got to not be so fancy and thinking ahead. Just think, just what basic information do I have? Okay, and it was triangle ABD congruent to triangle CBD. Same picture, completely different givens. Picture has not changed, same letters, same everything. I changed the givens. So let's start with this one first, because I like this one. Even though it's not the first one, I'm going to start with that one, because that's a freebie. I love it when they tell me something's congruent. So AD is congruent to CD. I like that. Next, we're given AC is perpendicular to BD. Okay, little different. But even though we use a symbol, we are using a vocabulary term. What is that vocabulary term? And what does it mean that it's perpendicular? That it forms a right. No, perpendiculars do not bisect. Unless it's a perpendicular bisector. We aren't told that. We got to be really, really, really careful here not to jump to false conclusions. And again, this is where knowing the vocabulary is so very, very important. What does perpendicular mean? It means it intersects to form a right angle. If you're not sure, look it up in the glossary of your book. Okay? So that means that angle ABD and angle CBD are right angles. And that's definition of perpendicular. Okay, that's what it means to be perpendicular. Now, I could go on to say that those angles are congruent, but I don't need to, because what else do I have in this triangle still? Well, same as last time, we had a shared side. So these are right angles. That's what we got from this. We haven't said they're congruent yet, but we don't need to. We could. It wouldn't hurt us to, but we don't need it. BD is congruent to BD. What was the reason again? Reflexive. Do I have congruent triangles? What reason? No. Okay, does side-side angle work? Unless that angle happens to be a right angle, which this one is. So this is HL. Okay. All right. These things are tricky. And again, you get good at these by practicing. And many times by failing and then coming back and seeing how to do it right, and then practicing more and failing and then coming back and seeing how to do it right. That tends to be our process with proofs. Some of you are going to get these very quickly. Some of you it's going to take a while. That's just an individual difference thing. We're prepared for all those. But, again, the only way to get better at these is to work them. If you are not doing this homework, you are not going to get this stuff. You're not going to become good at it. End of story. So, could be getting an A, barely passing, at best. Yeah. So, here we go. There's not a lot of problems, but they're all pretty much proofs. Page 238, 24, and 26. That's 2 problems. Here's 3 more problems and 1 there, so that's a total of 6 problems today. 3 more. 34, 35, 36. That's 3. Inclusive. Yep. So there it is, 6 whole problems. But remember, for these proofs, what do I want to see? I want to see drawing the picture and the 2 columns. Draw, label the picture, 2 columns. No picture, it's not done. I want to see you draw the picture. And seriously, folks, I know it's Halloween tonight, but nonetheless, I expect that these 6 problems are done. If you are not doing these, you are not going to be successful at these proofs. If you aren't even trying these, you're going to not do well here. Do what you got to do. I will. I just have to very quickly stop the podcast.